All right. Welcome back, everybody, to the deep dive. Um, you have brought some really, really interesting stuff for us to look at today. A whole bunch of research about kind of how our minds hold on to information and how we use it. So I think this is going to be a pretty deep dive. You ready?
Definitely. I think we're going to dive straight into working memory, which is going to be our focus today.
Yeah, working memory. So what are we talking about here? I mean, we've all heard about long-term memory, right? Yeah. The big storehouse. But what is this working memory thing?
Well, the deep dive this time is going to be all about working memory, what it is, how it works, and why it's so important for everything we do, for learning, for understanding, for really for problem solving, for everything. And, this research article you gave me it's like a great overview.
Yeah. So working memory, it's not like the giant hard drive in our brain, right?
Exactly.
That's long-term memory.
Yeah.
So what's the quick and dirty definition of working memory?
It's the stuff you can like grab onto
Yeah.
right now.
Right now.
Like the information that's in the spotlight of your mind.
Okay, so it's like the small amount of information we can hold and use right now
Yeah, exactly.
while we're thinking, while we're doing things. And like the cool thing is that it seems to be related to like how intelligent we are overall.
Oh, yeah.
How well we understand things, solve problems. It affects everything.
Yeah.
And it seems like it's a thing that it changes as we get older too, right?
Yeah, absolutely. And it has huge implications for education.
Yeah, huge. So I guess our mission in this deep dive is to really figure out what's the most important stuff about working memory. You
Mhm.
know, how does it develop? How does it work with learning? And what does it all mean for how we understand really how our own minds work?
Yeah, exactly.
And just to give you the big picture, we're going to touch on like where this whole concept came from and how scientists are still trying to figure out all the details.
Yeah.
So let's dive in.
Yeah.
Okay, so first things first, what is working memory? I mean, we threw out a quick definition, but let's unpack it a bit.
Okay. So at its core, working memory is a system in your mind that can only hold a limited amount of information.
Okay. Limited.
But it's responsible for actively holding and manipulating that information.
Okay, so it's not just passively sitting there.
Right. So you can carry out all these ongoing cognitive tasks, the things that you're thinking about, that you're doing right now, and it's distinct from, like you said, that vast storehouse of long-term memory.
Right, right. So this is really fascinating to me because, going way back, like 17th century, John Locke, the philosopher,
Well, yeah.
he talked about this difference between what he called contemplation and memory.
Okay.
And contemplation to him was like actively holding an idea in your mind, like right in your awareness,
Interesting.
versus memory, which is like trying to recall something that you're not currently thinking about.
Yeah.
So, even back then, they were starting to see that there's something different about actively holding information versus just, retrieving it from storage.
Yeah, that's fascinating. And, fast forward a bit to 1871, and there's this really cool experiment by William Stanley Jevons. Have you heard of this one?
No, tell me.
So he literally like tossed a bunch of beans onto a table and tried to estimate how many there were without counting them.
Without adding.
Yeah, just instant recognition. And you know what? He found that he could only really accurately grasp like maybe 3 or 4 beans at a time. And this was true for most adults.
Really, that few.
Yeah. And that kind of highlights a key point here that working memory really has a very limited capacity.
Very limited.
And, modern research has basically confirmed this, with much more sophisticated methods, but it's the same basic idea.
Wow, so we're really talking about like a really tight grip on information, like
Yeah.
just a few things at a time.
Yeah, exactly.
And then a bit later, William James, he talked about primary memory,
Oh, well,
which was kind of like what you're directly conscious of, and then secondary memory, which
Yeah.
is kind of like all that stored information.
interesting.
So again, like that primary memory idea is kind of an early version of this concept of working memory.
Yeah, I see the connection. And, it's kind of ubiquitous. When you look around, working memory seems to be involved in so many different aspects of our thinking.
Oh, right, right.
Take language, for instance. Like, imagine you hear a sentence like, after arguing with his sister, Tom reluctantly cleared the dishes from the table.
Okay.
To understand that sentence, your working memory has to do a lot of work.
Yeah, it's a long one.
Right. It has to hold on to Tom as the subject, then the action cleared, and then it has to connect that with the dishes from the table.
Right, but it's not in that order, right?
Exactly. Exactly. All those pieces have to be like temporarily held together.
Juggling.
Yeah, so you can construct the meaning of the whole sentence.
Right. It's like keeping all those juggling balls in the air
Yeah.
before they all fall down.
Exactly. It's like a mental postal service.
Ooh, I like that.
You know, it holds on to the address in the package until it arrives at the destination.
Until it reaches understanding.
Right.
Or think about doing math in your head.
Oh, yeah.
Like if I asked you to calculate, I don't know, 37 minus 19
Okay.
in your head, you don't have a piece of paper. What are you going to do?
Oh, okay, let me think. I would probably first realize that I can't subtract 9 from 7.
Right, right.
So I have to borrow mentally a 10 from the 3,
Right.
making it 17 minus 9, which is 8.
Okay, so you're holding on to the 8.
Right, holding on to the 8, but I also have to remember that the 3 in 37 is now a 2.
So you're holding on to two things.
Yeah, 2 things at least. So then I subtract 1 from 2, get 1,
Okay.
and then I combine the 1 and the 8 to get 18.
Right. So all that holding and manipulating numbers in
Yeah.
your head,
Yeah,
that's working memory in action.
exactly.
And it's not just for abstract things like numbers and words.
Mm-hmm.
Think about navigating like a grocery store.
Oh, yeah.
Right. You have your list. You're trying to find everything. You have to keep track of, okay, what aisle was that in?
Yeah.
Do I already go down this one? What else do I need? So you're constantly updating this mental map.
Absolutely.
And that's your visual spatial working memory working.
Exactly. And even something as basic as like looking at a scene, and noticing if something has changed,
Right, right.
you have to briefly hold on to that initial image in your working memory.
Right, to compare.
To compare it to what you're seeing now and spot the difference. And that could be anything from like a misplaced object to a potential threat.
Right. It's like that's how we notice that the milk is missing from the fridge.
Exactly. Yeah. And think about understanding like abstract concepts. Take like democracy.
Right.
Like, it's a system of government by the whole population or all the eligible members of a state, typically through elected representatives.
The big concept.
It is. Right. And to grasp that, you have to hold in mind all these ideas like government, population, election, representative,
As of pieces.
and understand how they all fit together. And initially, these concepts might be kind of vague, but your working memory lets you connect them and refine them as you learn more.
Right. So it's kind of like the initial construction site for new ideas, and then once that building is built,
Yeah, I like that.
then it gets stored away in long-term memory.
Right, for later use. So let's kind of shift gears a little bit
Okay.
and talk about how the concept of working memory itself has actually evolved over time.
The history of the idea. All right, take us back.
Okay, so one influential perspective came from Hebb in 1949, and he had a more neurologically based view. He was focused on how temporary memory worked in terms of these things called cell assemblies.
Cell assemblies. Okay.
So those are like patterns of neurons that fire together to represent an idea.
So it's like a team of brain cells all firing in sync to represent an idea.
Yeah, exactly. And he proposed that only a limited number of these assemblies could be active at any given time.
Right. So it's limited again.
Yeah, very limited.
So it's like, I don't know, a group of musicians learning a new song. Like at first, everyone's kind of playing their own thing.
Right, right.
But then as they practice, they start to fire together in these coordinated patterns.
Yeah, that's a great analogy. Like that's the cell assembly, the neurons firing together to represent the song, the idea.
Right, the idea. So that brings up an interesting question, doesn't it?
Mm-hmm.
Like, is working memory just everything that's active in our minds right now?
Yeah.
Whether we're consciously focusing on it or not? Or is it more like what William James was talking about, the primary memory, the stuff we're actually paying attention to and manipulating?
That is a great question, and there's debate about that.
Yeah.
But generally, when we talk about working memory, we're talking about things that explain behavior, things that we can see in how people act,
Right, observable.
not just, subjective experiences. So it's not strictly limited to just the consciously attended information.
Okay, okay.
Cowan, for example, in 1988, he proposed this model with 2 key aspects of working memory storage.
Okay, 2 aspects.
Yeah. So first, you have the activated part of our long-term memory, which might be similar to Hebb's idea of active cell assemblies.
Okay, so stuff that's been pulled up from the archives, but not necessarily in the spotlight.
Exactly. And then within that activated portion, there's a smaller, more focused subset of items that are in our direct attention.
Okay, so like the spotlight within the activated stuff.
Exactly. And he described the activated memory as kind of like a soup. right? A soup of different activate features, sensory details, sounds, visual elements, meanings.
Wow, that is a soup.
And then the focus of attention contains, just a few well-integrated items, or what we call chunks.
Dunks, yeah.
So you've got the whole soup and then a few chunks you're really focused on.
Right, and that reminds me of George Miller's work.
Oh, yeah.
Back in 1956, he wrote this famous paper about the magical number 7.
Yeah, plus or minus 2.
Plus or minus 2, right, for immediate memory.
Right, for immediate memory.
So he suggested that we can hold like around 7 chunks
Chunks, yeah.
of information.
Yeah.
So a random sequence of letters might be harder to remember than, say, like an acronym you're familiar with,
Oh, yeah, because that's already a chunk.
because that's already a chunk.
Exactly.
It's like USA or FBI.
Yeah.
It's already packaged up. So that's a big insight there, right? Like actively creating meaningful chunks is a powerful way to kind of get around the limitations of working memory.
Yeah, absolutely. You're basically like compressing the information.
Pressing, yeah.
But more recent research has kind of refined that a bit.
Okay.
And it turns out that without actively using strategies like chunking or silently rehearsing information, the typical adult limit is actually closer to just 3 or 4 pre-existing chunks.
Really? So 7 is like the best case scenario.
Yeah, like if you're really working at it.
If you're really using those strategies?
Yeah.
Okay, interesting. And speaking of the term working memory, do we know where that came from? Like who first coined that phrase?
Yeah, good question. So it seems like the first time it appeared in print was in a 1960 book by Miller, the magical number 7 guy,
Oh, right.
and his colleagues. And the book was called Plans and the Structure of Behavior.
Plans and the structure of behavior.
Interesting. And their idea was that, like, our everyday lives are structured around these hierarchies of plans and subplans.
Okay.
And working memory was the mental capacity that allowed us to keep these plans and subplans in mind.
Okay, so it's like the mental to-do list.
Yeah, exactly. So you can maintain the overall goal while you're carrying out the individual steps.
So think about like your morning routine.
Oh, yeah.
Right. That's like the master plan. You've got sub-plans like make coffee, get dressed, brush your teeth.
And even smaller steps within those.
Yeah. And Miller and his team, they were suggesting that working memory is what helps us keep track of where we are in that whole hierarchy.
Yeah, like remembering you still need to grab your keys while you're putting on your shoes.
Right, all part of the bigger plan of getting out the door.
Exactly.
So it's like the mental project manager in our minds.
Yeah, a really important one. Now, around the same time, there was another influential figure, Donald Broadbent, in Great Britain.
Okay.
He wrote this book in 1958 that really helped move psychology more firmly into the realm of cognitive processes.
Into the mind, right.
Exactly, into the mind. So he proposed this information processing model.
Oh, okay.
And it included this very brief sensory memory, like the stuff that hits your senses but doesn't really get processed.
Right, like a fleeting impression.
And then an attention filter, which picks out the important stuff.
Okay, so attention is playing a role here.
A big role. So then that selected information gets into this small capacity working memory where it's held, and then finally into the vast store of long-term memory.
Okay, so you've got like this flow of information.
Yeah. From the senses through attention to working memory, and then potentially into long-term storage.
Right. And what I find fascinating is that Broadbent's model was partly inspired by real-world challenges from World War II.
Oh, really?
Yeah, like, how pilots had to focus on critical air traffic control messages amidst all this other radio chatter.
That's a great example.
So his work really highlighted that there's this difference between this large capacity but very short-lived sensory memory and then this limited but more durable working memory that requires our attention.
Yeah, it's like attention becomes the gatekeeper.
The gatekeeper, yeah.
Deciding what gets in for more in-depth processing.
All right, so attention is crucial here. And then a little bit later, Baddeley and Hitch came along in 1974. And they really shook things up with their multifaceted model of working memory. They basically challenged this idea of a single short-term memory store.
Yeah, like one size fits all.
Right, and they provided evidence that different types of information are actually handled and stored in distinct ways.
Yeah, like, different tools for different jobs.
So this was a really big shift. It showed that short-term memory is not just this undifferentiated space,
Yeah.
but a system with different parts.
Yeah, different components.
And this has big implications,
Right.
right? Because it suggests that maybe we need different learning strategies,
Yeah.
depending on what kind of information we're dealing with.
Yeah, for sure.
So They found, for example, that trying to remember a sequence of spoken numbers was much harder if you were also trying to repeat another sequence of sounds at the same time.
Oh, wow.
But this didn't really interfere with remembering the spatial location of dots on a screen.
Okay.
So that suggests that there are separate systems for verbal information and visual spatial information.
Exactly. And they called the verbal one the phonological loop, and the visual spatial one the visual spatial sketchpad.
Right. And they also proposed this central executive.
Yeah, the boss, if you will,
The bo-
the one that controls and coordinates everything. And later, in 2000, Baddeley added the episodic buffer, which kind of integrates information from those other components and links it to long-term memory.
So it's like, instead of having one mental storage box, now we have a whole interconnected, team of specialists.
Yeah, exactly. Much more dynamic.
Much more dynamic.
Yeah.
So we've talked about a few models now. We talked about Hebb's cell assemblies. We talked about Cowan's activated long-term memory with the focus of attention. And we've got Baddeley and Hitch's multi-component model. So are all of these still in play or have things moved on even further?
Yeah, it's interesting because all of these models have kind of informed the current thinking, but there are still some debates going on about, how working memory really works.
Okay, so it's not all settled.
Not completely.
So what are some of the main differences between these models, and what are some of the big questions that researchers are still trying to answer?
Yeah, well, one debate that's been going on for a while is focused on whether we really have these separate dedicated storage systems in working memory, like Baddeley and Hitch suggested, or if it's more like Cowan's model, where it's all about activating different parts of long-term memory.
Right, right. So separate modules versus kind of levels of activation within one big system.
Exactly.
So what do we know about that? Is there any evidence leaning one way or the other?
Well, the research is complex, and it often depends on how you design the experiments. But there are some interesting findings. Robert Logge and his colleagues, they've done a lot of work on visual imagery, and their research suggests that our ability to form mental images and our capacity for visual short-term memory might actually be separate things.
Oh, interesting.
So visual imagery might involve activating these really detailed representations from long-term memory.
Like picturing your childhood home in detail.
Exactly. But visual short-term storage might be more like a temporary buffer that holds less detailed information.
Like remembering the shape and color of an object you just saw.
Right. And Cowan, he acknowledges this and suggests that, the specific demands of a task might influence whether we rely more on activated long-term memory or a dedicated visual buffer.
So it could be both, depending on what we're doing.
Yeah, that's a possibility. Another big debate has to do with whether different types of information interfere with each other in working memory.
Right, right. So if you're trying to remember a list of words and a list of pictures at the same time, do they kind of get in each other's way?
Exactly. And, Baddeley's initial model leaned towards the idea of more domain-specific processing.
Okay, so less interference.
Yeah, less interference. Like, verbal information is handled separately from visual spatial information.
Okay.
But Cowan's model allows for more general interference across different types of information.
Because it's all in that one activated pool.
Right. So researchers have been trying to figure out, how much do these different types of codes, verbal, visual, spatial, how much do they actually compete for resources in working memory?
Right. So some people are saying they're separate. Some people are saying they're all mixed together.
Exactly. And there's evidence to support both views. Some studies, like by Daneman and Carpenter, they showed that being able to read and remember words at the same time is a really good predictor of overall reading comprehension.
Interesting. So it's like those two things are tapping into a shared pool of resources.
Right. And then Engel's work has found correlations in working memory capacity across different domains.
Okay, so that suggests that maybe there's this general ability to process information efficiently and resist distractions.
Exactly.
It's not just about how much you can hold, but how well you can manage different types of information.
And filter out what's irrelevant.
Right, the mental juggling act.
Yeah. Now, another interesting model comes from Bourrier. And he and his colleagues, they've really emphasized this idea of attentional refreshing.
Attention refreshing.
Okay. So their model proposes that when we use our attention to kind of periodically refresh items in working memory, That takes time,
Okay.
and it helps to counteract this natural decay of information.
So it's like, clicking the refresh button on a web page to keep the content updated.
Yeah.
You're actively maintaining the information.
And they've found that the more cognitive load you have, the more your attention is occupied, the shorter your memory span tends to be.
Right. So the more you're actively thinking, the less you can hold on to.
Exactly.
So this is all getting pretty complex. Like there are so many different models and ideas about how working memory works. But I guess the big question for a lot of people is like, what are the fundamental limits?
Yeah, what are the boundaries of this mental workspace?
Right. Like how much can we actually hold in working memory at any given time?
Yeah, that's a key question. And how long can we keep it there if we're not actively doing anything with it?
Right. So it's like the how much and the how long. Are there answers to these questions?
Well, there's some consensus, but there's also still a lot of debate. So, regarding capacity, for a specific type of information, like a sequence of sounds or a set of objects, adults can typically hold around 3 to 4 meaningful units in their immediate focus.
Okay, so that magic number 7 is really more like 3 or 4.
Yeah, unless you're using some fancy chunking strategies. But even then, there's a debate about whether that limit is just inherent to our attention or if it's more about interference from trying to hold similar things at the same time.
Right. So like if you're trying to remember a bunch of numbers, they might interfere with each other more than if you were trying to remember a number, a color, and a shape.
Exactly. And Cowan, he's actually got some new work that's not published yet where he suggests that, okay, maybe the immediate focus of attention can only hold a few chunks.
Hmm.
But those chunks can be temporarily offloaded to kind of a less active state in long-term memory and then brought back into focus with attentional refreshing.
So it's like you're swapping things in and out of the spotlight.
Yeah, like a mental juggling act.
And that might allow us to handle a little bit more than that strict 3 or 4 item limit.
Yeah, potentially. Now, the question of how long information persists in working memory, that's also a bit tricky.
Okay, so if we just hold on to something and don't rehearse it, how long does it last?
Right. Some studies have shown that for verbal material, information might not decay that quickly if we prevent rehearsal or refreshing. But other research, especially with visual tasks, has found evidence of forgetting happening pretty fast, even without interference.
Okay.
And Ricker and Cowan, they've proposed that the rate of decay might actually depend on how well that information is consolidated or stabilized in working memory.
Okay, so the stronger the representation, the longer it lasts.
Exactly. And that consolidation process could be linked to attentional refreshing. So maybe refreshing isn't just about counteracting decay, but also about strengthening the memory trace.
Right, making it stickier.
Yeah.
Okay, so we've got the how much and the how long, and it sounds like there's no easy answer.
Yeah, researchers are still figuring it out. Now, this brings us to something that's often called the paradox of human performance.
The paradox of human performance, okay.
And it's basically this question of how can we as humans do all these incredibly complex things
Right.
when our working memory seems so limited?
Right, if we can only hold 3 or 4 things at a time, how are we composing symphonies and, building skyscrapers and writing novels?
Exactly. I mean, we're obviously dealing with way more than 3 or 4 things in our daily lives. So what gives?
Yeah, what's the secret sauce?
Well, the key here is that each of those units that we hold in working memory can actually represent a very complex chunk of information, especially if we have the necessary prior knowledge. And this goes back to Miller's idea of chunking, combining individual items into larger, more meaningful units.
Right.
And then Erickson and Kinch took this further with their concept of long-term working memory.
Long-term working memory. That sounds almost like a contradiction, doesn't it?
It does.
I mean, isn't working memory short-term by definition?
You'd think so, right. But their idea is that in situations where we have a ton of relevant knowledge in long-term memory, that knowledge can basically act like an extension of our working memory.
Okay, so it's like we're pulling in outside help.
Exactly. Like, think about resuming a conversation after being interrupted.
Right.
You might not remember the exact details of what you were just saying, but you can usually pick right back up.
Right.
And that's because your long-term memory of the conversation is providing the context.
The background.
Yeah, the background. So Erickson and Kinch called this long-term working memory.
Okay.
Cowan has a similar term, virtual short-term memory.
Okay. Virtual short-term memory.
But it's the same basic idea, using long-term memory in a way that resembles how we typically use working memory.
So it's like we're borrowing space from long-term memory to handle these more complex tasks. But if we can do that, why does the basic working memory limit still matter so much?
That's a great question. So that limit becomes really critical when we have limited prior knowledge.
Okay, so when we're learning something completely new.
Exactly, because then the capacity of our working memory directly dictates how much new information we can hold at the same time,
Okay.
either to use it together to solve a problem
Right.
or to link it together to form a new concept that can then be stored in long-term memory.
Uh-huh.
And this is exactly the situation we face in a lot of learning environments.
Right, because in school, you're constantly being bombarded with new information.
Right, like imagine you're trying to follow multi-step instructions.
Okay.
Especially for younger kids who haven't developed a lot of routines and associations.
Mm.
If you tell a preschooler, put your crayons in the box and then bring your picture to the teacher, they might get the first part,
Right,
but completely forget the second instruction before they're even done with the first one.
because they don't have the space in their working memory to hold both instructions.
Exactly. Or imagine reading a textbook where the author introduces like 5 new concepts in one paragraph.
Oof, I've been there.
Right. Your working memory is overloaded trying to remember all the definitions.
Yeah.
And you end up not really understanding anything.
Right, so working memory is the bottleneck, especially when we're dealing with new stuff.
Yeah. Now, Pazes and Sweller, they have this useful distinction between what they call biologically primary knowledge and biologically secondary knowledge.
Okay, so primary and secondary knowledge, what's the difference?
So primary knowledge is stuff that our brains are kind of naturally good at learning,
Okay.
like recognizing faces, acquiring language.
Stuff we're wired for.
Yeah. This kind of learning doesn't require a lot of working memory. But secondary knowledge is more like stuff we have to consciously learn.
Yeah.
Like grammar rules, historical dates,